Good evening. My name is Alex Debrew. I'm CEO of Xent, and today I want to show you the power curtailment capabilities of the Xent M wind turbine. The Xent M wind turbine is the 100 kilowatt turbine Xent produces for both distributed generation and off-grid power. To do this, we simply click on any turbine we have operating. Here we're looking at a turbine that is installed in the northwest of Scotland on the Isle of Harris. There's very good wind resources there, so we're going to use that wind turbine to illustrate how smoothly we can control the power output of our turbine, in spite of the fact that the turbine is a stall control machine. So it's a very simple machine, it's a very simple architecture. It has no pitch system. So that is a mechanism that is particularly failure prone and is located in the hub usually. So the Xent M does not have that, which obviously means that it cannot fail. So to gain access to these kind of parameters, we need to set up a VPN tunnel to the wind turbine. This is password protected, obviously. So once we enable the tunnel, we can open up, have a look at what's going on. You can see the turbine is in operation. It has been standing still because the wind speeds were just too high, but here we have good wind resources. We can click on the auto refresh of the Xent portal. We see that the turbine is operating more or less around its rated power. Wind speed is above rated. Rotor speed is around 53, 54 RPMs. You see here the clockwise, counterclockwise yaw demands. We're going to tune the interface a bit so we can have a bit better view of the powers. So to do this, we look at the power curtailment variables. So we're going to plot the generator power on a 10-second average, and we're going to plot the available power, which is the power that we could be generating if we were not curtailing. So these variables are now auto refreshing, and now we can go to the settings page where we can change the power settings. These are the usual settings that can be changed by the operator in the development settings, which are again password protected. We can find more advanced settings like the power curtailment feature. We can obviously make that available to any client who wants that. And this can also be modified obviously through Modbus via remote control. So we're going to set the power to 75 kilowatts. So we're going to ramp the power down from 100 kilowatts to 75. And here we can see what happens with the average power. So what the controller is going to do is simply is going to bring down the rotor speed so that the average power approaches the desired power level. So you can see right here we were at 55 RPMs, which you can see here, and immediately the power is going down. The blue line that's shooting up like this is just a 10-minute average, as this is the first 10-minute period the turbine is operating. You can see that the power is really coming down quite fast and is smoothly controlled. The available power is now higher than the power we are generating. So it is effectively in curtailed mode. So we started curtailment about here, and now, let's say about 1 minute later, we almost reached the desired power. We can curtail further and bring it down to 50 kilowatts. We can see now the yellow available power is still around 100 kilowatts, which is logic as the wind speed is still above rated. And we can see how the rotor speed keeps going down to effectively ram down the power and bring it down to the desired level of 50 kilowatts now. You can see how this transition is fairly smooth. I mean, there's always the ripple of the instantaneous power, which is effectively caused by the turbulence in the wind. But this is something that can be dealt with a small energy storage unit that can be coupled directly to the DC bus of our converter, and then this instantaneous power effectively becomes also very smooth towards the grid. To further illustrate how low we can curtail this power, now that we've reached almost 50 kilowatts, a very smooth ramp, we can even bring it down further and go down to 25. So now we're going to bring down the turbine, which is seeing 15 meter per second wind speeds. We're going to bring it down to 25% of its rated power. You can see the power keeps on decreasing. Wind speeds are still very high. Power keeps on coming down. Progress is still really stable. No sudden transients. You can see how within a time, let's say a time window of 1, 2, 3, 4, perhaps 5 minutes, we can very smoothly ramp the power down of the wind turbine and bring it down to 25 kilowatts. Almost there. There we are, 25 kilowatts. And now let's have a look at the ramp up. So now we allow again to bring the power up to 50 kilowatts. We'll see how the maximum rotor speed is allowed to vary and to gradually increase again. And this will effectively bring the power back up. So this is a process that we're perfectly controlling thanks to only the torque control in the converter, which is imposing a torque on the shaft of the generator. There's no need for a dump load. There's no need for a pitch control. There's no need for braking. There's no need for managing that energy. It's just being curtailed. It's being shed at the very source of the power, which is at the turbine blades, by running the turbine in the different CP coefficients. So it's a smooth process that doesn't take any additional hardware. You can see how gradually the power is coming back up. reaching 50 kilowatts. And then we can restore the operation and just bring it back up to its rated power. You can see how effectively the control power was far below the available power. And all this is just thanks to controlling the speed and the torque on the shaft. Again, this is a feature that's perfectly capable of being triggered remotely by an energy management system, effectively smoothing and reducing the power output of the wind turbines. You see the ramp up of the power, 80 kilowatts. And almost back to rated power. So within a time period of, let's say, 2329, less than 10 minutes, we were able to bring down the turbine to a quarter of its rated power and bring it back up smoothly without the aid of any additional hardware, just by giving it a control signal that can be done remotely and is perfectly integratable into a higher, superior energy management system. So far, this illustration of the power curtailment capability of the EOX M wind turbine. Thank you.